Hey guys, today I thought I'd show off a little GitHub project that I found that looked particularly interesting called Big Papa. Doesn't have very many stars, but the reason I found it so interesting is that it's sort of a self-hosted Google Analytics without giving all your data to Google. And to kind of illustrate what it does, it has none of the limitations that Google Analytics has. So for example, one limitation of Google Analytics is that you can only track up to 50 events per session, meaning time spent on, your property, your website. After the fact, you can perform ad hoc querying using Google BigQuery, which is a SQL-based database. And the other thing you can do that's particularly interesting is you can explore your traffic data, your event data of people using your web property or otherwise in Google Data Studio, which is a tool that I haven't really used, but it looks like an interesting way to explore a data warehouse. The other thing that interests me about this example GitHub repo, kind of proof of concept, is that it scales pretty much infinitely to an infinite size data set. And for another, it's very low overhead of maintenance. So we'll kind of follow through the tutorial here. I think it would be interesting to see just how easy it is to see data streaming from maybe a sample website we create to Google Cloud Services, and then using BigQuery and Google Data Studio to visualize and query the data. So first things first, we'll git clone Big Papa. We'll cd in there, and you'll see that there's an install script in the project root. As you can see, the way to invoke it is to pass it this argument, which I'm guessing is the name of a bucket to which, So the third argument to install.sh is the bucket name. And set-e, what this means is it'll fail on the first non-zero exit code of anything performed in the shell script. So it looks like it makes a BigQuery data set identified by the bucket name we provide. And then it also makes a Google Cloud Storage bucket using the same name. Then using gsutil, which is the Google Cloud Services command line tool, it looks like we make the bucket publicly accessible. I'm guessing in order for our beacon file, which is a 1x1 transparent image file, to be retrievable by our analytics JavaScript snippet. After we've properly configured the new bucket that we were creating, it looks like we go into the tag directory where we create an environment variable equal to the bucket name we've provided. We install some Node.js dependencies, and we perform the build, whatever that is, which we'll take a look at in a second. And then it looks like we additionally configure the cache and how long the beacon file should be cached in people's browsers. Then we create another bucket, which is to store our logs, our log files. This is the access requests that our beacon is emitting. So these could be, page views, these could be button clicks, these could be mouse over events. On mobile, I'm sure there's all kinds of events you can hook up to, like scrolling. And then similarly, we're configuring the ACL, or access control list, to, I'm guessing, allow BigQuery to query our Google Cloud Storage logs bucket. And then lastly, we set up the logging of access requests to our beacon bucket to go to our logs bucket. Additionally, final step, we go into our ingest folder, create a new BigQuery table that matches a table schema.json, which is probably how we declare the data format of our logs. And then we partition the logs by date time, I'm guessing. Or DT probably corresponds to a field in our JSON file. So actually, let's check real quick. In the ingest folder, we'll take a look at table schema.json. You can see it's just a JSON file with the names of the columns of our data. So that's our data format in the log files. And then last but not least is creating a serverless function. And it looks like in the ingest folder, besides having this manifest, we've also got a very simple function. Let's take a look at the ingest folder. We've got an index.js, which is what is the Google serverless function. Takes the log files from our log file bucket and imports them, writes them into BigQuery for querying. Let's give this a try. Let's try running shell install.sh, and we'll call our bucket Big Papa test. All things allowing, it should work fine. One thing I'll note as it's performing this is it's important that you've installed the Google Cloud Services command line interface, which should give you the gsutil and the bq command for BigQuery. So this shouldn't take more than a minute. We'll watch it as it progresses. This looks like it's performing a npm install, so installing our node dependencies. There may be a little wait time as they upload to Google Cloud Storage to the buckets that I was just describing. But what should result from this is the creation of a JS file on Google Cloud Storage with a unique URL, which will embed into our web pages. So if you're on WordPress, this would go on like your base template. If you're using Google Tag Manager, this would go in your Google Tag Manager. But one of the other benefits I should mention about this and why it's such an interesting thing for demoing is that you can also host it from your own domain. By default, it's being hosted from Google Cloud Storage. And the reason that's interesting is because ad blockers will generally block Google Analytics, like any vendor of analytics services. So you'll get more accurate data because people won't be ad blocking the domain name that you're hosting this script from. So looks like we're almost done. Looks like it's creating the JavaScript snippet. Looks like I have an older version of Node on my computer. Apologies. So it's creating the second bucket, which is where we'll persist the log files. And then our Google Cloud function, when new log files appear in our log file bucket, our Google serverless function will take the log file and persist it to BigQuery for querying, both in BigQuery and in Google Data Studio. So it's saying deploying function may take a while, up to 2 minutes. I'll edit it if it takes 2 minutes. Cool, and it's done. So looks like it prints out some helpful information. Let me take a look. We've got our source upload URL. We have our service account email. We've got our labels. We've got our event trigger. Cool. Let's go back to the README of the GitHub repo. And it says put this tracking code on any website. So we're going to need to figure out what our unique, I guess my tracker is our bucket name that we provided. So let's go ahead and copy this. So we can make a HTML file here. Let's throw our script in here. Let's make it a little bit more valid HTML. So important to remember our directory name. So let's try out, before even trying to access a web page with a script on it, let's go try getting the JS file on our own. It looks like it's there. It looks like if we look up Big Papa test, it's some minified JavaScript, but that looks right. So let's go ahead and serve up our current working directory so that we can access it in the browser. So if we go access localhost 8000, you'll see that we found the index.html file. If we look at the source of the page, there it is. So now if we go to Google Cloud Services, and we go to our storage, we should be able to go find our Big Papa test logs. Looks like there are no log files there yet. So we'll come back and revisit it once they are there. We can go look at our Big Papa test bucket, and we can see that the tracking JavaScript and the tracking GIF file are there. So one thing we can do as we're checking this out is look at our tag source and look at the source JavaScript file, which is written by Big Papa. So you can see that most importantly is our URL for our GIF file. This is called a beacon. You can see that there's a track event function. And by default, when you load this JavaScript, it fires off track event. So we could do other types of event tracking. So we also track scrolls. So let's try scrolling the page. We can check the network tab. I guess, there we go. This is a GET request that was made to our beacon. Let's take a look at the Json payload here. So you can see we tried firing a click, I guess. That's the event type E. I guess it might not fire scroll events because our file is not very large, so let's try sorting that out. Let's make a div style equals height 10,000 pixels. That should be enough. So if we reserve our index.html and we refresh the page, you can see that it fired the GIF. And now if we try scrolling, does an event fire? It doesn't look like it does. We'll have to dig into this a little bit more. But you can see a subsequent call was made of type scroll. Actually, it did work. I'm kind of curious why there was a delay. We can try scrolling again, see if it fires another. It does. So there must be some delay with it. But yeah, you can see the event type is scroll. So if we close that out, the developer console, we go back to our log bucket. Let's try refreshing it and see if there's any log files yet. There are none yet. While we wait for our logs to appear, let's go take a look real quick. We'll take another look at install.sh. We'll see exactly how logging is set up. So if we Google gsutil logging set, sorry, ringtone. If we Google gsutil logging set, let's Google delay. So I was able to dig up the documentation about the delay of access logs being written for a bucket you're monitoring. And it says they're generated hourly when there is activity to report in the monitored bucket. Usage logs are typically created 15 minutes after the end of the hour. So let's read their more detailed notes. Any log processing of usage logs should take into account the possibility that they may be delivered later than 15 minutes after the end of the hour. Usually hourly usage log objects contain records for all usage that occurred during that hour. Okay, so this might be a while. So we've made it. We now have log files in our Big Papa Test logs. You can see there's a number of files. So let's go ahead and go to BigQuery and see if we can check out the contents of our log file. You can see that there's a table here now called logs with plenty of contents. Sorry for my video of myself taking up a fair amount of this, but it shows us the schema. One thing we can do real quick is select star from bigpapatest.logs, I believe. Let's try running the query and seeing what event data we've got. Cool, there it is. So you can access it in tabular format. You can view it as JSON. Next steps, I think, would be cool to explore our data in Data Studio, a tool that I've never used before. Looks like you can do all kinds of slicing and dicing of tabular data, starting with maybe your standard dimensions. I think probably most interesting dimension-wise is the URLs that we're hitting up. So let's see. Oops, I didn't need to do the date range dimension. I meant to do the URL dimension. So you can see 6 times. And then let's also add a event dimension so we can see page views versus scrolls versus clicks. Awesome. So that works. Let's check out DT, which is the date time. And there's probably variations of date time that we can do. Like right now it's date, but we could probably group it by hour or day of week, that kind of thing, slicing and dicing it a lot like Google Analytics might allow. So I'm sure there's a ton of YouTube videos you can watch about Data Explorer. I won't cover them, but for those who are curious, I'd recommend checking out Big Papa. I'm going to give him one of their 5 stars. Hope you enjoyed.